Okay, so 3.6 Kirchhoff law. Kirchhoff law, there are two rules that we have to know. The first one is Kirchhoff First Law, and the second one is a Kirchhoff Second Law. So when it comes to Kirchhoff First Law and Kirchhoff Second Law, what is the things that we need to know? The first thing is you need to know what is the equations. Okay, so when it comes to first law, the equation that we use is a summations I in equals to summations I out. You are looking at the current flowing into a junctions and the current flowing out from a junctions. So the current entering a junction must be equals to the total current leaving a junction. Why? Because it obeys the conservations of charge. The numbers of charge entering a junction must be equals to the total of the charge that is leaving from that same junction. Okay, that's why we say conservations of charge. You look at the amounts of electron. The electron entering must be equals to the electron leaving. And then the second thing that we're going to look at is Kirchhoff Second Law. Okay, Kirchhoff Second Law, where we have summations delta V equals to 0. So when it comes to this one, what are we going to see is the potential rise and also the potential drop. That is the main things that we're going to look at in a circuit. So we want to see what happens. Okay, what does it mean by potential rise? What does it mean by potential drop? Because it will tell us how to determine the sign conventions in the equations. Okay, in the equations that we're going to form. So when it comes to potential rise and potential drops, now potential is related to energy. So when you're looking at this one, okay, it tells you the total potential rise must be equals to the potential drop. Okay, must be equals to the total potential drop. So when it comes to this case, we say it obeys the conservations of energy. All right, total potential rise should be equal to the total potential drop. That's why when you add them up, they give you a value that is equals to 0. Right, that is equals to 0. So now let's look at an example. Okay, I'm going to show you an example. We will see how to determine the sign convention from a second law. When it comes to first law, if you have a question with just one loop, then you don't need to apply first law. Okay, what does it mean by one loop? For example, this one. Okay, so let's say I start from a battery, EMF1, and then here I have a resistor. This is R1, and then followed by another EMF, another battery, EMF2, and then I have another resistor right here. This is my R2. Okay, done. End story. So this is what we call one loop. You have only one cycle here. Okay, there's no junctions in the loop. So if there's no junctions, of course you cannot use first law, because first law is talking about conservations of charge at a junction. The amount of charge entering a junction is equal to the amount of charge leaving a junction. But if you want to say this is a junction, can or cannot, well, you can say it's a junction, but now this junction, they're connected to each other. Okay, so the amount entering must be equal to the amount leaving. That is the idea. Okay, that is the idea. So this is a one loop question. So when it comes to this one loop questions, we don't apply first law. We will straight away proceed to a second law. So how to use second law? How to determine the sign convention based on potential rise and potential drop? What does it mean by potential rise and potential drop? So in order to apply this equation, we need to choose a point in our circuit. Okay, we need to select a point. For example, I'm going to select right here. This is my starting point, for example. Okay, the starting point. Oh, yeah. One more thing. If you look at this question, okay, the directions of current is not given. So in some rare occasion, the direction is not given. Most of the time, questions will tell you the directions of current, okay, most of the time. But in some rare occasion, you won't be given the direction. And what should you do then? Then you need to give it a direction. You yourself is going to give it the directions, all right, not any other people, all right? The books, it won't give you, and then, well, that is the diagrams that we have. We don't know the directions of current. Then how are we going to determine the direction? It's quite simple. If you look at this diagram, okay, oh, I'm going to change the directions, I think, to make it easier for you to see how to determine the direction. Okay, let's say like this, right? So, for example, if you have a case like this, then how are you going to determine the sign? Well, First thing, you check the value for EMF1 and EMF2. If you are given the value, then that would be the best. Okay, for example, now if according to the question, it tells you EMF1 is equals to 10 volt, and then EMF2 is equals to, let's say, 7 volt. Now you have two EMF with different value. So how are you going to determine the directions of current? You go for the one with larger EMF. 7 and 10, obviously 10 is a larger value. Okay, 10 is larger than 7. So EMF1 is larger, meaning that you're going to determine the directions of I based on the current flow through the EMF1. Okay, so EMF1 is right here. So this is positive terminal, negative terminal, meaning that the directions of current is anti-clockwise. Okay, it should be anti-clockwise. Since you are not given, you don't know whether it's true or not. Okay, you don't know whether it's true or not. So what you can say, you can just assume the directions of I is a clockwise direction first. That is your assumption. Nothing's wrong with that. If you want to draw anti-clockwise, can or cannot? Of course you can. Okay, the only difference is that you're just going to get a negative value at the end. If the question asks you to determine current, okay, to determine the values of current, then you are going to get a negative value. But other than that, the value, the way you solve it, everything's there the same. Okay, the only difference is the sign conventions in your final answer if the question asks you to calculate I. So I will show you an example after this, don't worry. Right now, we are just going to see how to determine positive and negative in our equations. So since this one involves just one loop, okay, so we cannot use the first law. So we are going to apply Kirchhoff Second Law. According to Kirchhoff Second Law, we have summations delta V equals to 0. So what we want to check what happens in EMF, and we want to check what happens when the current passes through the resistor. What happens to the potential, which is the IR. Okay, the IR. This IR, it is because it is equals to V. Okay, so we want to see what happens to EMF, what happens to V across every resistor. So before you determine the sign convention, the things that you must have is the loop. Okay, that's why second law also known as loop law. So you need to draw a loop. This loop, again, it is up to you whether you want to draw a clockwise loop or an anti-clockwise loop. It won't affect anything. Okay, it won't affect your final answer. It won't affect the way you solve it. It won't affect anything. The only thing is the sign convention for EMF and also the V right here. Okay, but anyway, you're still going to get the same answer. Okay, it doesn't matter whether your green color path is in a clockwise or anti-clockwise direction. It totally doesn't matter, right? So this green color path, most of the times I like to call it your own imaginary path. You imagine the directions of the current flow. Okay, the orange color currents right here usually will be given by the question. But sometimes you might disagree, right? You might think that maybe that is not the way, the path. Or sometimes when you have two battery like this, you're unsure which one is larger. So you might disagree with the diagram given, right? So this green color path, I like to call it your own imaginary path. All right. So this green color path, it is up to you. So usually I will go for I will choose the directions, okay, that is the same as the directions of current. Okay, same as the directions of current. So now my current is flowing in the anti-clockwise direction. So there's a path, green color path. I would like to draw it in a anti-clockwise directions as well. I think that is the best. Okay, I think that is the best. So this is the anti-clockwise direction. So if you choose clockwise directions, also can. Just that later on, if I got positive for EMF, you will get negative. I got positive IR, you will get negative, and vice versa. All right. Okay, now let us see. Now that I have labeled everything, I have the directions for current. I have the loop right here. I have also determined the directions for this loop. I'm now going to determine the sign convention for every single component in this circuit. So just now, I've already decided this one would be my initial point, my starting point. Okay, my starting point. So what am I going to do right now? I'm going to follow the directions of current, and then I turn one round until it goes back to this point. Okay, so you see, it will pass us through how many components. So start from here. So the current is flowing, And when it reached EMF 1, what happened? Now you look at the battery, the terminal of the battery, the terminal of this EMF. Now this green color line that I draw just now, let's assume it's a current flow. When a current flowing through the EMF and is flowing from lower potential to higher potential, means that it's gaining potential, it's experiencing potential rise. Negative, of course, is lower, right? Positive is higher. So from lower potential to higher potential, it experiences a so-called potential rise. Okay, so experience so-called potential rise. So the potential increase when it passes through this EMF. The current passes through this EMF. So meaning that we have positive EMF 1. Okay, we have positive EMF 1. So as the current keeps flowing, okay, as it keeps flowing, and now it reaches first resistor in our circuit, okay, R1. Now R1, the resistor, okay, resistor, like I told you guys before, it is a form of consumer. So EMF is a supplier. Now R1 is a consumer. It uses up the energy. Whenever current passes through it, it uses up the energy, right? So it should experience a potential drop. If, okay, there is a condition. If the orange color I, and the loop, they are both pointing toward the same direction, then we can say it experienced a potential drop, and the values here would be a negative value. So we have negative IR1 because it experienced potential drop. Okay, because it experienced potential drop, and the directions of this orange color I and our loop, they are both pointing towards same direction. Therefore, I can stick to its original sign, which is a negative sign, right? So now this current, it keep flowing, and when it arrives at this second battery, what happens right now is you look at the battery. This is positive terminal, this is negative terminal. So meaning that now my current is flowing to a place from a higher potential towards a lower potential. It is experiencing a so-called potential drop. So even though it is a battery, but now because of the direction, it experienced a potential drop. Okay, it experienced a potential drop. Therefore, EMF2 is a negative value because it drops. Okay, because it drops. So minus EMF2. So it keeps flowing, and now it has come to the last resistor. Okay, it has come to the last resistor. And if you look at this resistor and also the loop, both of them, they are pointing toward the same direction, the current and the loop. Meaning that now it is experiencing a potential drop, and then the sign convention for this potential drop is a negative sign. Okay, negative IR2. All right. So if I and loop, they are in the opposite direction, then you will have a positive IR. Okay, because the loop and the I, they are against. Therefore, you will have a negative IR if they are in the opposite direction. Okay, if they are in the opposite direction. I will show you how later on, don't worry. Okay, but right now, we just learn how to form an equations. Okay, how to form an equations. So now the current keep flowing, and now it has come to the initial, the starting point again. It has to go back to the initial point. Then that marks the end of this one loop. So we can now say it is equals to 0. Okay, it is equals to 0. Why equals to 0? Because energy is conserved. Okay, it gains how many energy? How much energy? Then it will use up all of the energy. Why? Because energy cannot be created or destroyed. Okay, so it receives how many energy from the battery? It will use it up, all of them. Okay, if they are going back to the same point. So that is the meanings of conservation of energy. So this is the equations that I obtained from the given diagram right here. Okay, so I have a plus EMF1 minus IR1 minus EMF2 minus IR2. Okay, and this IR actually is our V. This is a V1. Okay, and then this is my V2. V1, V across resistor 1. V2, V across resistor 2. Negative value. Why? Because it's experiencing a potential drop. Resistor, by common sense, by right, it should use up energy. When it uses up energy, energy drops. Okay, that's why it experiences a potential drop. So when it comes to the battery, okay, you look at the directions of the battery. If it's flowing from negative to positive, mean that it's gaining energy because it's moving from somewhere with lower potential towards higher potential. But if it is flowing from positive to negative, means that it will experience an energy drop, the potential drop. It uses up energy. Okay, it uses up energy. So now let's see, does it make sense, okay, to have a negative value? So let's say now you have a battery. Okay, you have a battery right here, another battery right here. Why we say potential drop? Okay, why we say it needs energy to overcome the energy from the other battery. You try to imagine now you have an electron. Okay, this is electron. The reasons why electron can move is because of the energy supplied by the battery. Let's say this battery, it gives 10 volt. Okay, so by right, the electron, it will move to the right hand side with 10 volt of energy. Okay, but if this one is a 7 volt battery, then what is going to happen? It will push the same electron with 7 volt of energy. 10 volt and 7 volt, they are fighting each other. Okay, they are pushing each other. So the one with larger value will win the battle. Okay, so this 10 volt EMF, it wins the battle. Therefore, my electron, it will keep moving towards the right hand side. Okay, when electron moving to the right, your current is moving to the left. So it follows the direction of this 10 volt battery, right? That is the idea. That's why we say it will experience potential drop if it is moving from a positive to negative sign. If these two batteries, they are facing toward each other with the same terminal, all right? So it will experience a potential drop. But if they are facing toward each other, they are being arranged in the same direction, for example, okay, if they are being arranged in the same direction, then what is going to happen? The current, it will just keep adding up. Okay, the electron will just keep gaining more and more energy. If this is 10 volt, this is 7 volt. Okay, so when the electron is at this position, okay, maybe it's moving with 10 volt of energy, the electron. And then after it passes through this second battery, second EMF, now this electron is moving with 17 volt energy. Okay, 17 volt voltage. All right, so the current that is moving from right towards the left-hand side, it will just keep adding up if this is how you arrange the battery. Okay, so that is the idea of potential rise and potential drops, and when to use positive, when to use negative. You look at the directions of the loop, and also you look at the terminal of the battery. Okay, terminal of the EMF. So directions of a resistor, it depends on the current, the directions of current, and also the directions of the loop. It depends on two things. Okay, it depends on the I and also the loop. So if they are pointing towards same direction, then it is a negative IR, because by common sense, it should be dropping. Okay, it should be dropping. So if they are against each other, means that your imaginary path and the actual path, they are different, then it will become a positive value. Okay, it becomes a positive value. So this green color is your imaginary path. Okay, you imagine how the current flow. This orange color, actually, it should be an actual path. Okay, kita kata actual path. So kalau actual path and imaginary path pointing towards same direction, then yes, you get negative. Why? Because it is dropping. But if your imaginary path and your actual current, they are flowing in the opposite direction, then what is happening is, okay, by right, it should be negative IR. But because your imaginary path and the actual path, they are against each other, it becomes negative IR. Okay, therefore, you have a positive IR. If they are against each other, okay, you have an additional negative. That's why straight away we say it is positive IR. Right? So orange color punya biasanya akan diberi oleh soalan, okay, dan dia mewakili actual path. So hijau punya yang loop yang saya lukis di sini, okay, loop yang saya lukis di sini, dia adalah Anda punya imaginary path. Anda yang rasa macam mana current sepatutnya flow di dalam circuit ini. That's why saya kata dia terpulang pada Anda. Anda nak lukis clockwise ke anti-clockwise tak salah pun, sebab dia adalah Anda punya imajinasi. Okay, you imagine it. So kalau Anda punya imajinasi dengan I yang orange ini, dia menghala ke arah yang sama. So, kamu dapat negative IR. Sebab apa? Sebab dia common sense saja. Apabila ada current melalui satu resistor, dia akan use up energy. Biasanya kalau dia use up energy, dia akan mengalami drop, potential drop. Okay, dia akan drop, turun potential dia. So kita akan dapat negative IR. Tetapi kalau Anda punya imaginary path dengan actual path dia terbalik, okay, dengan actual path dia terbalik, Anda akan dapat satu negative I. Okay, negative I ni disebabkan Anda punya laluan dengan actual path tak sama arah. So negative, bila Anda buat equations, dia akan jadi positive IR. That's why kalau loop dengan orange color punya I, dia terbalik arah dia terbalik, Anda akan dapat positive IR. Even though it is still a potential drop, okay, but then we write it as a positive IR. Okay, because the way you draw the loop, the way we form the equation, okay, is a slightly different than the actual direction. Okay, slightly different than the actual direction. So tak ada masalah pun, okay. So walaupun dia panggil potential drop, okay, tetapi apabila I orange color I dengan loop kita bertentangan arah, kita tulis dia sebagai nilai positif. Right? So that's it. And that is how we use equation summations V equals to 0. Now, let us move on to the next thing. Okay, move to the next thing, proceed to the next part of Kirchhoff Second Law. If you look at revision books, or if you watch the video from other colleges, some of them, they are not using summation delta V equals to 0. Okay, they are not using this equation. What are they use? Okay, what are they using is they use equation summations EMF equals to summations IR. Okay, summations EMF equals to summations IR. This is the equations that they use. Does it mean that they are wrong? No. Okay, both equations, they are correct, but the way that you use to determine the sign convention, it's different. Okay, it's different. So you might have this equation, summations delta V equals to 0, or you can use summations EMF equals to IR. Both of them, they are correct. But one thing that I wanted to take notes, all right, now let's look at here. Summations delta V equals to 0. Okay, I have one equations right here. And then I have summations EMF equals to summations IR right here. What is the main difference between these two things? Okay, when it comes to this equation, okay, the battery, this is the battery. Battery, they also give it a sign, a direction. Okay, they draw the direction from negative to positive. That is how they determine the direction. And then, when it comes to delta V, equations with delta V, what are we doing here is we check the terminal. Okay, we say here is negative terminal, here is positive terminal. So when it comes to summations EMF equals summations IR, well, even though you're still looking at the negative and positive terminal, but rather than terminal, they focus more on the directions of the arrow. Okay, so they say the arrow is pointing from negative to positive. Actually, the idea is the same, okay? But then the crucial part is the directions of the loop. For battery, it's still okay. Why? Because the way you use to determine the sign convention, they are still the same. So this is your loop direction. Okay, your loop direction. This is your loop direction. So loop direction, if it's pointing from negative to positive, okay, then you will have positive EMF. So in both cases, you will have same positive EMF. All right, both of them, both diagram, you will have positive EMF. So first method, the one in the gray color, how do I know it is positive? Because both arrow, they are pointing towards same direction. That's why it's positive. But in terms of concept, it's nothing much. Okay, that's why in KMPP, we teach you to use the red color method because it teaches you the concept. It lets you understand what is going on. The reasons why I have positive, it is because of potential rise. How do I know it's potential rise? Because it's flowing from negative towards positive, from a place with lower potential towards higher potential. So it's gaining potential. If it's gaining potential, you have positive EMF. So the one in gray color, okay, the method that you use is just to memorize the concept, to memorize the direction. That's why I don't encourage you guys to use this one now. All right. And the crucial part would be how to determine the directions for IR. If you use the one in gray color, this is your resistor, okay, and then this is the current. The one in the red color, again, I have the same diagram, and then this is the current, this is the R. The crucial point in this resistor, okay, in these two equations, the main difference between these two equations is what happens on the resistor. Okay, when it comes to this gray color set equation, again, they like to give direction to the resistor. Okay, so they say the directions of resistor is following the directions of current. This is the directions for this resistor. That is according to this method. Okay, so saya bagi dia arah dulu. Sebab bila dia datang kepada set warna grey ini, apa yang Anda buat? Anda bagi arah kepada setiap komponen dulu sebelum Anda selesaikan dia. Okay, but actually that is not quite right. Okay, it just helps you to solve the question, but it is not that right in terms of concept. So they give the directions to R. Okay, dia bagi R direction. Directions dia ikut arah I. Itu saja. Okay, directions R ikut arah I. And then what happened next? Okay, next you are gaining a loop. You have a loop again. Okay, you have a loop again. So let's say now this is your loop. Directions of the loop. And this is the directions of the loop. When it comes to this gray color set, okay, because the direction, they are pointing towards same direction. Once again, you have positive IR. Because now they are looking at the arrow. They say now arrow, they are pointing towards same direction. Therefore, you have positive IR. But when it comes to the red color set, okay, red color set, directions of the loop and the directions of current, they are pointing towards same direction. It means that now the current is experiencing a potential drop. Therefore, when it comes to this red color set, you will get negative IR. Because this negative, it represents potential drop in the circuit. All right, potential drop. Just now potential rise, now potential drop. So rather than just memorizing the directions of the arrow without knowing the concept, I would encourage you guys to stick to the red color version, okay, to the red color equation. It doesn't mean that the gray color one is wrong, you know. It is also right in terms of solving the question. Dari segi kita buat penyelesaian soalan. Okay, tapi dari segi nak faham konsep, dia kurang sedikit. Dia kurang sedikit. Sebab Anda tak nampak potential rise and potential drop kalau Anda guna kaedah yang warna kelabu ini. Tapi warna merah punya, memang kita stick to the idea potential rise and potential drop. So now let's see what happens if they are against the direction. Okay, so I'm just going to repeat it again. So this is the I, this is the R. For the red color one, it's also the same. This is the R, this is the I. Okay, so what if now your loop is pointing towards the other direction? Okay, this is the loop. So when it comes to the gray color set, they will say now the directions of the R is also going to the right, okay, because it follows the directions of current. So when it comes to this gray color set, now because they are against, they are not pointing towards same direction, so it comes into conclusions that now is negative IR. But when it comes to this red color set, like I told you just now, when current flowing through this resistor, it should be negative, okay, because it experienced potential drop. But now because your imaginary path and the actual path, they are against each other, they are not pointing towards each other, they are not pointing towards the same direction, therefore it is a negative I. Okay, so negative IR, then you obtain a positive IR when it comes to the red color set. So you have a positive right here. Okay, you have a positive right here. So that is the difference. That is the difference between these two equations. So it doesn't mean that either one is wrong. Both of them, they are correct. It depends on which one you use. Okay, dia terpulang pada mana satu kamu guna. So bila Anda tengok semua video dekat YouTube, Anda kena be extra careful when it comes to Ketchup Law. Saya memang tak galakkan Anda pergi tengok video dari kelas lain atau dari college lain. Okay, sebab ada dia masih guna kaedah warna grey ini. Dan apabila Anda tengok video warna grey ini dengan video yang warna merah ini, Anda sendiri akan keliru. Bukan saya keliru, bukan apa. Anda yang keliru. So, saya memang sangat tak galakkan Anda tengok video belajar Kirchhoff Law. Sebab Kirchhoff Law, dia punya key point, dia punya main idea, dia punya tempat yang paling penting adalah cara menentukan positive sign and negative sign. Dan apabila Anda guna equations berlainan, Okay, equation summations EMF sama dengan summations IR atau equation summations V sama dengan summations zero, dia kedua-dua kaedah ini, kedua-dua equations ini dia guna kaedah berlainan. Kalau kaedah berlainan, habis. Nanti kamu yang pening. Sebab kamu memang generasi sedang pening. Alright? So, stick to one method. Kalau kamu betul-betul nak tengok video, kamu tengok satu video saja. Jangan pergi tengok berbagai jenis video. Alright? Kalau kamu tengok buku rujukan pun, pastikan dia guna kaedah yang anda biasa. Kalau dia guna kaedah yang tak sama, anda potong dia punya, anda tulis anda punya. Supaya anda sendiri tidak keliru, terutamanya sebelum exam. Kalau anda tak berhati-hati dengan part ini, memang anda akan pening nanti. Alright, you will get very confused. Okay, you'll get very confused. You'll mix up the sign convention. So now I give you some times. Okay, I give you 5 minutes to write down the summary. Okay, to write down the summary, you can write it down a bit, especially these two methods. Okay, I show you both because I don't want you to get confused. So anda boleh buat sikit catatan juga supaya kalau anda buat revisions ke apa, anda nampak anda tak akan rasa keliru. Sebab sekarang saya ajar kamu, nanti kamu keluar kelas kamu akan lupa sudah kalau kamu tak buat catatan. Alright, so you write down a bit. I give you guys 5 minutes, okay? 5 minutes to write it down. All right. So now let us see how to solve a question that involve a Kirchhoff law. So first, if you look at the steps given, first one is say choose and labeling the current at each junctions in the circuit given. If it is not given, okay, if it is given now, most of the times will be given. Only in some rare occasions, questions will ask you to determine it. For example, in example 11. So we will try both, okay? We will try both. See what happens if I have current flowing in the clockwise direction and I have a current flowing in the anti-clockwise direction. And then choose any one junction if you have two loops question. Okay, if you have two loops. If you have just one loop, then you can skip step number 2. Step number 3, choose any closed loop, any two closed loop if you have more than 2 in a circuit, and design a direction clockwise and anti-clockwise. So designate a direction means that you are choosing a path. You're drawing a loop. Okay, you're drawing a loop to travel around the loop. So that is your traveling direction. Okay, just now I say imaginary, your own imaginary directions. Here they say your traveling direction. Okay, you assume it travel from where, so also imaginary path lah. Okay, and then you apply Kirchhoff Second Law. So basically, when it comes to equations with one loop, you just need one equation from second law. If you have questions with two loops, then you need one equation from first law. Okay, because it says choose any one junction, and then you need two equations from second loop. Okay, you need two equations from second law because you have two loops. Okay, because you're choosing two loops here. So one equation from first law, two equation from second law if you have equations with two and more loops. And then solving simultaneous equation. So this simultaneous equation is the part that we're going to learn how to use calculator. If question asks you to determine three different current, three different I. Okay, if not that case, not that type of questions, then you have to do it manually. But if question asks you to determine I1, I2, and I3, meaning that you can solve it straight away by using calculator. It will save a lot of trouble, right? So let's look at example 11. Example 11, now you're given a battery 11.5 volt. If you look at this question, now you have a comma right here, and then with a 2 ohm. So what does it mean? It means you actually have an internal resistance right here. Okay, you have an internal resistance right here. So you have two batteries. So I'm going to call this EMF1. Okay, I like to give it a label. Everything in my diagram, I like to label it. So this will be my R1, small letter R1. And when it comes to a problem solving, remember, you are going to treat it just like any other resistor. Okay, just like any other resistor. So this is my internal resistance with an EMF, and then an external resistor 8.5 ohm. So this is my capital letter R1. And then here I have another battery. Once again, it comes with a comma and 4 ohm. So I have EMF2 and I have R2. And this R2, again, I'm going to treat it just like any other resistor. Okay, any other resistor. So 15.1 ohm, this is my R2. 6.22, this would be my R3. So done. I'm done analyzing my diagram. I'm done determining, checking how many components I have, what is the values that I have. My next step would be drawing a loop. Okay, but of course, before the loop, you need to draw the directions of the current. So what is the directions of the current if you look at the diagram? Well, now I have both battery and both of them, they're heading towards same direction. So that makes my life so much easier. So I'm going to assume now my current is flowing in the anti-clockwise direction according to the battery. Okay, so this is the directions of current, my current flow, and my current flow. That is the direction. Okay, that is the direction. So next step, what am I going to do? I'm going to draw a loop. Okay, the loop. So this loop, to make it easier, I let it follow the directions of current. So I'm going to draw an anti-clockwise loop. Okay, I have anti-clockwise loop right now. So now I have everything's ready right here. I can then proceed to forming an equations. If you look at the diagram, I have just one loop. One loop means that I don't have to form equations for Kirchhoff First Law. Straight away, I'm going to start from Kirchhoff Second Law. And remember, you always have to write the equation. Summation delta V equals to 0. Okay, summations delta V equals to 0. So that is the equation. Okay, that is the equations that we must have. Why? Because in exam, this one is considered as concept. You'll be given 1 mark K1. Okay, you'll be given 1 mark K1. All right, now I'm done writing down the law. Okay, the equations for Kirchhoff Second Law. Let us go back to the diagram. I'm going to start from the same corner again, this corner. Okay, now first, what happens right here? Okay, my current start to flow my loop, okay, because I follow the directions of this orange color loop. So my loop start to move from this point towards, okay, small letter R1. So when it passes through this internal resistor, well, the name called resistance, of course, is going to experience potential drop. Potential drop now, the I and the, okay, if you look at the directions of the I and the directions of the loop, they are both heading towards same direction. Therefore, it is a negative value, negative IR1, because it is experiencing a potential drop. So it's dropping, so the current keep moving on, keep moving, and when it arrives at EMF1, it's moving from negative toward positive terminal. It is moving from a lower potential towards higher potential. Therefore, this is a positive EMF1. It's gaining energy. Okay, it's gaining energy. So it's keep moving. Now it's come to the R1. When it passes through R1, what happened? It experienced potential drop. And when you check the directions of I1 and your loop, both of them, they are heading towards same direction. Therefore, this is a negative IR1. Okay, negative IR1. So current keep moving, and now it's come to your second battery, EMF2. Once again, if you look at the diagram, it is moving from negative toward positive terminal, from lower potential towards higher potential. So it's gaining energy again. It's experiencing potential rise again. Therefore, you are going to plus EMF2. Okay, plus EMF2 because of the potential rise. And then it keeps moving and passes through your internal resistance. This EMF2, it comes with internal resistance. Okay, so this internal resistance, when the current passes through it, it will experience a potential drop due to this internal resistance. So it will have a negative IR2 right now. So as the current keeps flowing, okay, and when it passes through R2, once again, it experiences potential drop. Therefore, minus IR2, and then it keeps flowing and passes through R3. So minus IR3. Okay, and at last, it goes back to its initial position, its original position. So it is equals to 0. Okay, it is equals to 0. So once you have these equations, you can then substitute the value into the equation. Okay, you sub all this value into the equation. So negative I is an unknown because the question asks you to determine the current. So negative I, and then R1 I have, okay, now I'm going to straight away write it without bracket. So R1 is 2. So 2I plus 11.5 minus 8.5I plus 15 minus 4I minus 15.1I minus 6.22I equals to 0. Okay, so if you calculate everything correctly, eventually you should obtain I equals to 0.74 ampere. But if you look at the question also asks you to determine the directions of the current, right? So how do I know whether it's correct or not? Okay, you look at the value. Now you have a positive value. Okay, if you have the positive value, that means the directions that you draw just now for the I, it is correct. Okay, the original, the green color I in the diagram. The green color eye, you draw it in the anti-clockwise direction and you obtain a positive value, which means you got the right direction. Therefore, this is the anti-clockwise direction. Okay, you look at the diagram, it's anti-clockwise. And positive, it tells you that now you're making a right choice. So you are going to stick to anti-clockwise. Okay, anti-clockwise direction. If you got a negative value, then it means the actual direction and the directions that you draw in the diagram, okay, the directions of the eye that you draw in the diagram is opposite. Okay, is opposite to each other. So in that case, if you draw in a clockwise direction, then the final answer should be anti-clockwise. Well, that might be a bit confusing, okay, the way I explain, right? So now let us look at the same questions, but now I'm going to draw the eye in the opposite direction. So this is the eye. Okay, this is the eye. This is the eye, and this is the eye. All right. And then for this loop, okay, I'm going to let's see, how am I going to draw the loop? All right, if I draw a loop in the anti-clockwise direction, in the clockwise directions also, now let's see. Okay, let's see what is the difference between these two examples. Okay, let's see what is the difference between these two examples. So again, I'm going to start from this point. Okay, I'm going to start from this point. But now, I'm going to follow the directions of this loop, yeah? The orange color one means I follow the directions of the loop that I draw. Okay, yang saya tengok arah di sini, actually saya ikut arah orange color punya loop yang saya lukis. Kalau saya lukis anti-clockwise, dan saya akan ikut arah anti-clockwise. Kalau saya lukis clockwise punya loop tadi, dan sekarang saya akan gerak ikut arah clockwise. Okay, dia bukan ikut arah eye, dia ikut arah loop. Okay, yang orange color yang saya lukis sekarang ini, yang ini starting point, saya akan gerakkan orange color point ini ikut arah loop yang saya lukis tadi. So now my loop is a clockwise loop. What am I going to do? I'm going to move in a clockwise direction. So clockwise, this one, as it passes through this resistor, both I and the loop, they are moving towards same direction. So I have positive IR. Okay, let me label the diagram first. So just now I call this R1, EMF1, and then this is R1, this is EMF2, R2, R2, and this is R3. Okay, so when it passes through the first resistor, I have negative, okay, because same direction. So experience potential drop. Negative IR3, okay, negative IR3. And next, okay, what happened is that it will keep moving. And it passes through second resistor. Again, they are pointing towards same direction. So negative IR2. Okay, negative IR2 keeps moving. And now when it comes to this battery, what happened? It's moving from positive terminal towards negative terminal. Okay, positive terminal towards negative terminal. So what is going on? Now you will have a negative EMF. Okay, negative EMF 2. Okay, negative EMF 2, and then the internal resistance minus IR2. So the main difference is right here. Okay, just now you have positive EMF 2, now I have negative EMF 2. So as it keeps moving, okay, it keeps moving, and when it passes through R1, I have negative IR1. How do I know it's negative? Because same direction. Okay, directions of the blue color I and the loop, they are pointing towards the same direction. Therefore, I have a negative IR1. And then when it passes through this battery, what happens? It's moving from higher potential, which is the positive terminal, towards a lower potential, which is the negative terminal. Therefore, I have negative EMF2. Okay, negative EMF2. And also it comes with an internal resistance, so minus IR2. Okay, minus IR2. So it keeps moving, and then it goes back to its starting point. That marks the end of my equation, equals to, equals to 0. Okay, equals to 0. So it is equals to 0 now. So if you plug in the value and you rearrange it, eventually you will get I equals to negative. Okay, negative negative 0.74 ampere. Okay, now that you have a negative sign, what should you do? Okay, so we have just now we have positive EMF, now we have negative EMF. Just now we have positive I, now we have negative I. Does it mean that we are wrong? No. Okay, don't worry about that. You are still having a right answer based on the diagrams that you draw. So when it comes to Kirchhoff law questions, you always have to show the diagram. Okay, kamu sentiasa kena tunjuk diagram sebab kamu nak tunjuk pemeriksa arah yang kamu pilih. Kalau kamu tak tunjuk diagram, pemeriksa tak tahu arah yang kamu pilih, dia akan anggap kamu dapat jawapan yang salah. Alright? So Anda kena tunjuk pemeriksa arah yang kamu pilih dalam diagram Anda. So when it comes to this question, now you have a negative. What does that mean? It just means that the directions of the eye that you draw just now, okay, yang blue color eye ini, the directions that you draw just now is not true. It doesn't represent the actual direction. Okay, it's against, it's opposed the actual direction. So if you obtain a negative value, then it means the eye is not moving in the clockwise direction. In fact, in reality, it should be moving in the anti-clockwise direction. Okay, so dia akan terbalik dengan arah yang kamu lukis tadi. So kamu lukis clockwise, tapi kamu dapat nilai negatif, maka dia bermaksud actual direction yang sebenarnya adalah terbalik dengan lukisan Anda. Anda lukis clockwise, yang actual punya anti-clockwise direction. Okay, yang actual punya anti-clockwise direction. So alright. So now again, I give you 5 minutes to write it down. I want you to write down both method. Okay, Anda sendiri catat sikit sebab saya rasa ada banyak ruang kosong kot. Oh, kamu punya buku, saya tak pasti. Okay, kalau tak ada ruang kosong, Anda buat catatan di kertas. Saya nak Anda catat kedua-dua supaya Anda tahu what does it mean if you have a positive and a negative value. Okay, what is the difference between positive and negative value? Because I don't want you to get panic in your exam. Okay, when you solve questions, when you try out the exercises. Sebab pelajar sentiasa panik. Oh, matilah cikgu, matilah miss. Saya dapat negatif, kawan saya dapat positif. Apalah masalah dia? Saya buat salah kah? Atau kawan saya buat salah kah? Tak ada orang salah. Don't worry about that. Okay, both positive and negative, they are both correct. Okay, the only difference is that the way you draw the directions for I. Mungkin kamu draw clockwise, kawan kamu draw anti-clockwise. Itu saja. Tak ada masalah pun. Okay, tak ada masalah pun. Alright, so I give you 5 minutes to write down the answer. Write down both of them. Sendiri buat satu lagi. Okay, tengok mana yang kamu sudah guna. And then buat satu lagi untuk yang Anda tak guna punya, belum guna punya. Okay, 5 minutes for you to do it. Then we will proceed to the last example, example 12. Okay, so setakat ini saya harap anda jelas ya sebelum kita masuk ke loop yang lebih complicated sedikit. So kalau ada apa-apa masalah, sila tanya. Alright, so this is a two loops questions. So when it comes to two loops questions, remember the things that I told you just now. If you have a two loops questions, it means that you're going to need three equations, or you can form three equations from it. Where first law, okay, first law, it will give you one equation. And then second law, it will give you two equations. Well, actually, you can get three equations from it though, but we just need two. Which three? Why I say three? Okay, you have a first one. This is the first loop. This is your second loop. This is your third loop. That's why you should be able to obtain three equations from second law. But we don't want three. We just want two out of three. So it is up to you which two you want to use. Okay, dia tak kisah. Anda boleh je pilih mana-mana. So again, as usual, I like to label the diagram. Okay, I don't like it when my diagram, when all this component, it doesn't have the name. Okay, so that is for me lah. Okay, I truly love to give them a name. So this is R1, this is R2. I'm going to call this R3, R4, EMF1, EMF2. Well, this question, it does give you the I already. So you have I1, I, and I2. Okay, you're given three different I already. Okay, so what am I going to do? First thing, okay, when it comes to two loops question, you look at the junction. This question is being very nice to you. It tells you that you have junctions A and junctions B already. Okay, so this is the junction. We need to know where is the junction in order to apply first law. So we have junctions A here, we have junctions B here. Okay, so what are we going to do? We can now apply Kirchhoff First Law. Kirchhoff First Law, it tells you summations I in equals to summations I out. If you look at the diagram, now it is up to you whether you want to use junctions A or junctions B. Okay, so let's say I'm going to use junction A. So if I look at junctions A, what happened right here? I have current I1. Okay, I1 now. Remember, junctions, the current always flowing from junctions to junction. Okay, if along this part, along this line, the current is I1, then you have to know that from B to A, you have three paths. Okay, so all these three paths, they are all going to share the same current. Kalau di sini ada I1, bermaksud path yang dia mula sampai path yang dia tamat itu, dia adalah I yang sama. Dia bermula dari mana? Yang I1 ini, dia bermula dari B. Okay, dia tamat dekat mana? Dia tamat dekat A. So meaning that these three paths, they are all going to use I1. Okay, these three paths, they are all going to use I1. Oops. Whereas for the other side, okay, on the other side, you have I2 right here. Okay, so you try to identify the starting point of I2. I2 start from where? It starts from B. So it means that this path is using I2 and then it ends at A. So before A, the current is also I2. Okay, the current is also I2. So that is how we determine which I to use. Okay, now let us go back to Kirchhoff First Law. If you look at junctions A, okay, let's say now I'm going to use junction A. I'm going to refer to junctions A. What happens at junctions A? The current in means current entering the junction. If you look at this diagram, the current entering the junction is I1 and I2. Both of them, they are heading towards junction A. Okay, both of them, they are heading towards junction A. Therefore, I in is equals to I1 plus I2. Equals to, now the one leaving is I, okay, I is leaving, therefore it is equals to I, okay, it is equals to I. So I1 plus I2 equals to I, this is my first equation. And of course, I don't want to leave it in this form, I want to rearrange it, okay, I want to rearrange it like this. I1 plus I2 minus I equals to 0, okay, this is my first equation. Okay, I rearrange it in this form because question asked me to determine current I1, I2, and I. If not, you can leave it in the previous form. Okay, saya susun, saya rearrange dia siap-siap sebab apa? Sebab saya tahu nanti saya kena buat begini juga berdasarkan soalan yang dia tanya. cari I1, I2 dengan I, memang equations Anda kena susun dalam bentuk ini. Alright. Kalau dia tak tanya I1, I2, and I, Anda boleh kekal ke equations pertama tadi. Tak payah rearrange, tak ada masalah. Okay, so now I rearrange it first because I know I'm going to do it anyway. So, okay, now I'm done with first law. Okay, one equation from first law. So now I have this one equation. I can then proceed to second law. So how am I going to do second law? I'm going to choose two loops. So I'm going to choose the left-hand loop, okay, left side loop, and the right side loop. So for the left side, okay, for the left side, to make it easier, I'm going to make my loop to move in the clockwise direction. Okay, it will make it easier for me to solve this question. And then for the one on the right-hand side, the loop on the right-hand side, okay, the loop, again, I have a loop here. I'm going to choose, okay, let's say I'm going to choose this one is anti-clockwise is better. Okay, anti-clockwise is easier. If you choose clockwise, is it wrong? No, nothing's wrong with that. Don't worry about that. Okay, don't worry about that. So I'm going to label the name of the loop. I'm going to call this loop 1. I'm going to call this loop 2. Okay, so that the examiner know what are you doing. All right. So let's form an equation for loop 1. Okay, so loop 1. So if you look at loop 1, okay, if you look at loop 1, let's see what happened. So I'm going to start from, it's up to you where you want to start from. Okay, I'm going to, let's say, start from point A, junction A. So the loop that I draw just now is moving in the clockwise direction. So I'm going to start from point A and then moving in the clockwise direction. Okay, so from A, I'm going to start to move. When it passes through R3, what happened? It experienced potential drop. If you look at current I and the directions of the loop, both of them, they are pointing towards same direction, meaning that this is a negative, okay, negative IR3. Okay, IR3. I use I right here because the current flowing through R3 is the current I. Okay, so negative IR3. So as I keep moving, and now it passes through R4. But the current flowing through R4 is I1. Okay, it's I1. So what am I going to do right now? Well, you look at the directions of the current. It's going to the left-hand side. The loop is also pointing to the left-hand side. Both of them, they're pointing towards same direction. So negative, okay, minus I1 R4. Because current flowing through R4 is I1. Okay, the current flowing through R4 is I1. So let's keep moving. Now it's keep moving, and now it has come to my EMF1. When it passes through EMF1, what is happening? It's moving from lower potential towards higher potential. So it experiences a potential rise as it passes through the battery. So plus EMF1. Okay, plus EMF1. No internal resistance, so you can just ignore it. And then it keeps moving and it passes through R1. Once again, it experiences potential drop. And because I1 and the loop, they are pointing towards same direction, potential drop. So we'll stick to negative I1 R1. All right. So as I keep moving, and now I'm back to point A, junctions A. So it is equals to 0. Okay. So what am I going to do next? I'm going to plug in the value. Okay. I have R3. So negative 1.2I minus 9.8I1 plus 12 minus 3.9I1. Okay, 3.9I1 equals to 0. Okay, here I want to be careful. If the questions just ask for I1, I2, and I, then you can just leave it in this form. But since now the question is asking for this value, I'm going to rearrange it. Okay, I'm going to rearrange it. The way I rearrange it, okay, I'm going to do it like this. 9.8 and 3.7, it's equals to 13.7I1. Okay, plus 1.2i equals to 0. Oh, not equals to 0, sorry, my bad. It equals to 12. Okay, equals to 12. I rearrange it so that the value with unknown is lying on the left-hand side and the value itself is lying on the right-hand side. Okay, the value 12 is lying, the constant value is lying on the right-hand side. The one with unknown, you keep them all on the left-hand side. So this would be my second equation. Alright, nilai yang ada unknown, kamu biarkan dia di sebelah kanan. Yang di kiri punya adalah nilai sahaja. Okay, nilai 12 sahaja. Yang tak ada unknown punya. So that is my loop 1. Now I'm going to do the same thing for my loop 2. Okay, loop 2. Okay, so now I'm going to do for loop 2. So loop 2, again, I'm going to start from a point A. Okay, I'm going to start moving from point A. And just now I choose the loop in the anti-clockwise direction. So I'm going to move the loop in the anti-clockwise direction. So I'm going to start from A, and then now once again, it passes through R3. Okay, it passes through R3. So R3, when it passes through, the directions of the current and the directions of the loop, they are pointing towards same direction. So it experiences a potential drop. So I'm going to stick to negative value, negative IR3. Okay, negative IR3. And then it keeps moving. Okay, nothing's along this path. And then I'm going to keep moving. And now it has come to my second battery, EMF2. As it passes through the EMF2, what is happening? It is moving from lower potential towards higher potential. So it experiences a potential rise. So plus EMF2. Okay, plus EMF2. And now it keeps moving until it goes back to point A. But before that, it passes through R2. As it passes through R2, it should experience potential drop. You look at the directions of current and the directions of the loop. Both of them, they are heading towards the same directions. Therefore, we will stick to the negative value. Okay, same direction, stick to the drops, negative. So negative I2 R2. Okay, negative I2 R2. And then it goes back to A. That marks the end of this journey. So it is equal to 0. Next step, again, I'm going to plug in the value. Negative IR3 plus EMF2, negative I2 R2 equals to 0. So negative 1.2I plus 9 minus 6.7I2. Okay, because I2 is the current that's flowing through R2 equals to 0. Once again, I'm going to rearrange the equation so that the unknown, they're all staying on the left-hand side and the known value is on the right-hand side. So after I rearrange it, I should obtain 6.7I2 plus 1.2I equals to 9. This would be my third equation. Okay, this will be my third equations. Okay, so now when we arrive at this step, what am I going to do? I'm going to rewrite these three equations in a more tidy form, starting from the first equation. So I have first equation, I1 plus I2 minus I equals to 0. Okay, this is the first equation. The second equation's 13.7I I1 plus, now I don't have I2, right? So I'm going to plus 0 I2. Okay, I need all these unknown to be arranged at the same position. Okay, at the same position. So plus 1.2I equals to 12. Alright, you cannot arrange them in the different positions. Okay, kamu tak boleh first one I1 plus I2 minus I. Yang kedua, kamu letak I di depan, I1 di belakang. No. Okay, they must follow the sequence. Okay, they must follow the sequence. In the first equation, you put I1, I2 minus I. Then the following equations. Okay, the first unknown should be I1. The second unknown should be I2. The third unknown should be I. So third equation, well, I don't have I1, means that I have 0 I1. Okay, followed by I2, so plus 6.7 I2 plus 1.2I equals to 9. Okay, you see all these unknown, they are being arranged in the same sequence. Okay, bermula dengan I1, kemudian I2, baru I. Right? So now that you have come to this step, you are almost done. Okay, only one more step is needed. Okay, kita perlu lagi satu step. Step apa? Okay, kita akan tengok calculator. Right? So take out your calculator. Okay. So take out your calculator. Okay, this is a wait, yeah, I forgot to clean it up. Clear. Okay, so now you take out your calculator. Okay, you take out your calculator. Now this calculator is well, I wouldn't say it's old version. It might be different than yours. Okay, so I will give you another type of a calculator in a group. Okay, because I just have one example right here. Ada satu lagi jenis calculator yang saya tak ada gambar dekat laptop saya. Okay, yang satu lagi yang anda punya calculator adalah calculator yang bergambar. So sekejapnya saya bagi anda dalam grup anda. Okay, so yang anda punya calculator warna hitam atau yang sama dengan saya punya ini, anda boleh tengok screen. Yang tak sama punya, anda tengok Telegram anda. Okay, ada satu lagi jenis calculator yang saya tak ada sampel di laptop saya. Okay, now that you have the calculator here, let's see how are we going to key in the value. Okay, according to these three equations. Okay, kita tengok 3 equations di sini. Kita tengok calculator ini. First thing, anda pergi ke mode. Oops. Anda pergi ke mode. Okay, anda pergi ke mode. Tekan mode, you press the mode, you have a panel like this. Okay, ini dalam perkataan punya sedang sikit. Ada satu jenis calculator dalam gambar-gambar punya, itu anda tengok group. Okay, anda tengok group. So tekan calculator, you have this menu come out. Bagi yang warna hitam punya calculator, anda kena tekan 3 kali kalau tak silap saya untuk jumpa perkataan EQN. Number 5. Tekan mode, cari EQN. Okay, cari EQN. So you press 5. Tekan 5, kamu akan keluar ini. Untuk calculator hitam, for unknown, anda tekan 3. Okay, unknown, tekan 3. Kita tak tengok degree, kita tengok bilangan unknown. Unknown, kamu tekan 3. For this calculator, obviously, number 2 is the equations that we want to use. Okay, number 2 is the equations that we want to use. So you go for number 2. Tekan nombor 2. Dia akan keluar benda begini. Okay, dia akan keluar benda begini. So what does it mean then? Okay, so if you recall the equations that we see just now, okay, let me clear it again. I'm going to show you again. So you go to mode, go to EQN. If you look at the equations that show you here, A and X plus B and Y plus C and Z equals to DN. N is the amount, is the equation, numbers of equations, okay? So if you compare with these 3 equations right here, what does it mean? It's actually A1X. Your I1 is your X, okay? Plus B1Y minus C1Z equals to D1. Okay, so your unknown is the X, Y, Z. That's why you have 3 unknown. For the black color calculator, you need to press 3 unknown because we have 3 unknown in the equation. So this one is your A2X plus B2Y plus C2Z equals to D2. A3X plus B3Y plus C3Z equals to D3. Okay, so you have the unknown right here. So I1, I2, and I, they are actually your unknown X, Y, Z. I1 is X, I2 is Y, I is Z. It is based on the way you arrange it. Okay, ada pelajar mungkin dia tulis I di depan sekali. Kalau anda bubuk I di depan sekali untuk ketiga-tiga equations, maka X adalah I anda. Okay, X adalah I anda. So it depends on how you arrange it, how you sort it. So now that you have this panel, okay, Kalau warna calculator warna hitam, kamu terus dapat A1, senang. Kamu key in saja, ikut numbering dalam equations Anda. When you got this calculator, and when you got this form, this panel, how are you going to fill in the value? You look at the calculator. This one is A, column A, row 1. So this box, it represents A1. A1 is I1, means that you have only one I1. You press in 1. Okay, tekan 1. Enter. Okay, nilai 1 sudah masuk ke dalam calculator. Plus I2. I2 means that you have just one I2. 1 again. Enter. C negative. Oh, it should be plus dalam equations kamu. Okay, oops. It should be plus. So original equation is plus, but now you have a minus I. So this one, it represents negative 1. Okay, kalau kamu ada tanda negative minus dalam equations, then you need to include the negative sign in your calculations. Okay, in your calculator. So negative 1. Okay, because minus I. Minus I means that you have only one I, but now you have a minus sign here, so it's negative 1. Enter. And then here 0, that is your D1. Okay, D1, 0, in 0 juga. Enter. Now you have moved on to the second row. Column A, second row, that is your A2. So 13.7, enter. 0I2, so key in 0, enter. 1.2I, so 1.2, enter, equals to 12. So D2 is 12. Tekan 12, enter. Now it's a third row, A3. A3 is 0, 0, enter. B3, 6.7. Oops. Okay, 6.7, enter. And then 1.2, enter. And the last one is 9, enter. Okay, 9, enter. And then you enter one more time. That is your answer. Okay, that is your answer. So your I1 is 0.72. Okay, 0.72. That is your I1 because it's your X. So I1 equals to 0.72A. And then you enter one more time. This is your Y. Y is your I2. I2 is 1.03A. Okay, 1.03A. And then, okay, and then you enter one more time. It's a Z. Z is an I in your equation. So you have a 1.75A. So I is equals to 1.75A. Now, as you can see, straight away you obtain the values for all three of them. Okay, so that is how you should do in your exam. Okay, you don't solve it manually. If you solve it manually, sometimes it's quite complicated and you might use up to 1 or 2 pages derivation in order to get the final answer. Okay, so when it comes to determining 3 different I, use your calculator. Make use of your calculator. Okay, make use of your calculator. That is how you solve it. All right. So if suddenly you got something wrong, okay, you found something wrong in your equations, you want to key in it, okay, you just enter. Now it brings you back to the original panel. Okay, so you can just move until the one that you want to change the value. All right, gerak ke tempat yang kamu nak ubah nilai dia. So that's it. Okay, that is how you use calculator. All right. So what I want you to do right now, okay, once again, I give you 5 minutes to write it down. I want you to try the calculator, sendiri guna calculator, tekan sampai dapat 3 nilai ini. Okay, bagi guna calculator yang jenis tak sama, Anda tengok gambar dalam buku Anda. Okay, macam mana nak sampai ke step ke-5 kalau Anda guna calculator yang ada gambar raja itu. Alright. So now you try to solve this question first. You write down the answer first. And then we will proceed to a second question. Okay, we'll proceed to questions B and questions C. So 5 minutes for you to write it down. Okay. So now let us move on to a second questions. Questions B. Okay, questions B is very simple. What I want to focus on is question C. Okay, so questions B, just a very short and simple question. The potential difference across 6.7 ohm resistor. 6.7 ohm resistor, that is our R2. Okay, that is our R2. So just now we have R1, R2, R3, R4, EMF1, EMF2. So R2 is the R2 is this resistor, 6.7 ohm resistor. So the current flowing through R2 is I2. Okay, so basically V2 equals to I2 R2, which is equals to 0. Oh, sorry, 1.03 times 6.7, which is equals to 6.9 volt. Okay, 6.9 volt. Now, let us look at question C. Question C, we have three methods. Okay, there are three methods that can be used to solve question C. Ada tiga kaedah. So it's asking for potential between point A and B. If it's between point A and B, then it doesn't matter which one is initial, which one is final. But if the questions give you from A to B or from B to A, then you have to be extra careful, because delta V is always equals to V final minus V initial. All right. But if the questions didn't mention anything, it just say between A and B, then it is up to you whether you want to take A as initial or A as a final. It doesn't matter. Okay, now when it comes to this question, there are three methods that can be used, three ways that can be used to solve it. So it's asking for potential between A and B. Between A and B, now this is your A, this is your B. So you try to think how many paths can be used to travel from A to B. Okay, berapa path yang Anda boleh guna untuk travel dari A ke B. First path is here. Okay, this is your first choice. So first choice, it can travel from A through R1 and then through EMF1 and then goes back to B. That is your first method, first path that can be used to travel from A to B. Okay, second path is straight away from A to B through R3. That is your second choice. The last choice is the through R2 and then passes through EMF2 go to B. So three paths means that you have three methods that can be used to solve this question. All right, and I'm going to show you all three. Okay, I'm going to show you all three. So let us start from the blue color path. Okay, the blue color path. Now, if I choose the path from A to B through the blue color one, then what am I going to do? I don't draw loop like now. Okay, in these questions, you don't draw loop anymore. Okay, you don't draw any loop. You just let the line, the path start from A. This is your A, and then it's up to you whether you want to choose it in the clockwise directions or anti-clockwise direction. Okay, if the question say from A to B, then you must start from A and then going towards B. Okay, must start from A going towards B. If the questions say from B to A, then you need to change the directions. Okay, kamu tukar arah dia. Kalau soalan bagi kamu from B to A. Alright. So now that I have this one, okay, how am I going to do it? I'm going to start from VA. Okay, I start my journey from VA. So VA is my starting point. And then what happens right here? I travel from A and then passes through R1. As it passes through R1, the directions of current, directions of current through R1 is going to the right-hand side. This is your I1. But it is against the path that I've chosen. My path is going to the left, but I1 going to the right. So in this case, it should be positive. Okay, it is a potential drop, but because of the opposite direction, then we use the positive sign instead of negative sign. So positive I1 R1. Okay, so now I keep traveling. When it passes through this EMF1, it is moving from positive towards negative. The path that I've chosen is moving from positive towards negative, from higher potential towards lower potential. So again, it's experiencing potential drop minus EMF1. Okay, minus EMF1. As I keep traveling, when it passes through R4, once again, directions of I1 and the directions of the path, they are opposite to each other. Okay, path going to the right, I1 going to the left. So plus I1 R4 again. And then it reached the final position, therefore it is equals to VB. Okay, it is equals to VB. So it depends on which one is initial or which one is final. Okay, it's totally depends on the question. If the question just like this one, just say between A and B, then it is up to you whether you want to use VA minus VB or VB minus VA. But if it did mention from A to B, okay, kalau soalan bagi kamu ayat from A to B, oops, from A to B, then you need to use VB minus VA. Kalau soalan bagi kamu from B to A, then it must be VA minus VB. But if it's just between, then it doesn't matter. Okay, then it doesn't matter. So I'm just going to use VA minus VB. It is equals to EMF1 minus I1 R1 minus I1 R4. And eventually you should obtain 2.1 volt. That is the first path. Okay, that is the first choice. The second choice that I can use is the green color path. Again, green color path, I myself need to draw the path first. Okay, let's say I'm going to say I'm traveling from A to B again. This is the green color path that I'm choosing. Okay, so I have the path and then I look at the I. So let's say now I start to move from A, and then when it passes through R3, the directions of current is going down. The path that I draw is also going down. Both of them, they're heading towards same direction. So VA, I start from VA minus IR3. And then it has come to the destination B, so it is equal to VB. Rearrange the equations. I have VA minus VB equals to IR3, which is also equals to 2.1 volt. Okay, which is also equals to 2.1 volt. If I've chosen, okay, if I choose the red color path, okay, if I choose the red color path, so what I'm going to do, I'm going to draw the path again. Okay, let's say this is a path that I've chosen. Okay, I've chosen in this way. Saya pilih punya. If you want to start from B to A, also can. Nothing's wrong, all right? Okay, so the third path that I can use right here is, okay, I'm going to start to move from A, and then as it passes through R2, what happened? Okay, the directions of current, I2 is moving towards the left-hand side. Okay, and it is against the directions of the path that I draw here. Okay, I draw my path to the right-hand side, but current is going to the left. So VA, okay, start from VA. When it passes through R2, because the directions of the path and the directions of the current, they are against each other. So plus I2 R2. Okay, plus I2 R2. So as the path keep moving, when it passes through EMF2, it's moving from higher potential towards lower potential. So minus EMF2. Okay, and then as it keep moving, the path keeps moving, traveling, and as it reached point B, then it has come to an end, VB. So if I rearrange the equation, VA minus VB, it is equal to EMF2 minus I2 R2, which is equals to 2.1 volt as well. So it doesn't matter which path you, okay, which path you choose, all of them will give you the same answer. Eventually, you will come to the same answer. Okay, kalau kamu dapat jawapan tak sama, bermaksud Anda mesti ada salah buat di certain step dah. Okay, di salah satu komponen. Kalau Anda buat semua betul, sepatutnya ketiga-tiga path ini dia akan bagi Anda jawapan yang sama, sebiji. Okay, so you start from point A, you end at point B. Okay, kalau kamu tengok equation saya, I start from A, ends at B. I start from A, ends at B, start from A, ends at B. All right. So I think that that's all. Let me stop the recording first.